A cylindrical wooden block of density of the density of water. Half the density. So here we'll make it. So this is the density sigma. This will be 2 sigma. Or 2 rho will write it. Rho. This is 2 rho. What is the work done? And just look at the area of cross section of container. That also has brought into picture. And there's a very simple problem. Let's analyze it. When X length is immersed, when X length gets into that one, so initially what will happen? H by 2. So I'll write all the conditions first. So that will be easy for us. And finally, the H length, what happen will get immersed. It will get totally into this one. Okay, I'll draw a parallel diagram to make you understand. Again, you'll get confused. Okay, I'll write separate here now. Huh? It's a purely diagram based. Huh? We have to fight with the diagram. Through diagram only things will be easier. So initial level of liquid. Okay, meanwhile, I'll draw the diagram. You also think it. There's a thing. Okay, initially the block is half immersed. This much is half immersed. Some X length, let it be immersed here. There's a rise in level of liquid. You can see now here. How much it was. See, it's all about diagram. Huh? I'm telling that it's all about the diagram. Once if you are sure about this diagram, some X length is immersed, no? No. Okay. So this is what? Uh, what all you can say when X length is pushed down, X length will get into the liquid. Will I agree? Just don't get scared anything or don't need not to bother anything. Just only This was the initial level of liquid. So what should happen to the level of water? Should increase. Definitely, we are very sure. Okay, let's get into how much level of water should increase. This is what my question. Look at the cross section of the container is twice that of cylinder. So how much further increase in volume of the cylinder? AX. We will write below here. This is A. This is 2A, no? So how much of volume immersed? AX of volume is immersed. Then this additional volume immersed, what happens should come here. Then what is the area of cross section? So now area of cross section of cylinder is how much? 2A, no? So tell me like what can be this H? This Y, I'll write it. So this Y is what we should determine. How to calculate that Y? So AX, shall I write, should be equal to area of cross section of cylinder into area of cross section of the cylindrical area of cross section of wooden cylinder minus area of cross section of the wooden block into Y. So therefore X is equal to Y. So how much rise in level of liquid? Y. So what is Y I should call? Rise in level of liquid in cylindrical vessel. Able to understand this? I think we are this one. Okay, now tell me like what is a buoyant force now? So what should be the buoyant force? Already some h by 2 length is immersed, no? So what is the additional buoyant force? Additional buoyant force should be rho g additional buoyant force. So initially there's a buoyant force is acting. Fb dash weight of the solid. So now how much it will be? Fb dash plus now what is the delta Fb? Delta Fb, what you can write, density of liquid 2 rho mm, 2 rho area of cross section 2 rho A G into 2x. What is the density? Okay, density of water rho naught. Okay, okay. I think yeah, we'll keep it rho naught, not 2 rho. I think it's not needed in terms of rho naught only. We'll express it. It's not needed. We'll agree this that this is something very important. Okay, let's get into the calculation. What is the work done? So who will push that external force only? So now what will happen? The wooden block is pushed vertically so that it gradually gets immersed in water. Calculate the amount of work done in pushing the block. So as I'm pushing the block, as I'm pushing the block, so what should happen to this delta FB? Will keep on increase. It is a function of X. It's a function of X. So some of you are asking, sir, okay, justify. Come forward like this. 2 rho naught AGX. No. What is the work done? The action agent should overcome this much, no? And this is a variable force. So what is the work done? dW equal to delta FB into dx. 2 rho naught AGX into dx. Anybody, what should be the limit? Limit is very important. If you say h by 2, I think there's a problem is there. Any reason for that? Because you look at this one, as the cylinder descends x, the liquid will rise by x, no? So somehow what happened if I push the cylinder h by 4, if I push the cylinder by h by 4, the h by 2 length will get immersed, because if you push the cylinder by x inside the liquid will rise by x. So to get fully immersed, what happened, h by 2 length, what happened, should get into the liquid further h by 2. Then how much I should push? Only h by 4, the displacement. So this should not be 0 to h by 2. This should be 0 to h by 4. Able to understand the limit? What is this? Work done by extension to push the cylinder by distance dx. For the cylinder to get into the liquid, h by 2 should, so this everything should go into the liquid, no? But what should be the displacement of this point? Should be h by 4, because if the cylinder moves by x, the liquid will rise by 2x. So therefore the limit should be 0 to h by 4. So this will become a rho naught g h square by 16. Some question he has made it. I'll scroll down. We'll take the next one. One more question is there related to this. One more small idea. Let me share that also. If we have, there's a liquid, there's a cylinder. Sigma rho, where sigma greater than rho. Area of cross section of cylinder, let it be A. This everything is a liquid. I just release with the lower end touching the free surface. Then what will be the velocity of this cylinder when it gets fully into the water?